Welcome back to the programme now. Scientists in Canada have raised a tantalising prospect, reversing memory loss linked to depression and ageing. They say that new therapeutic molecules developed at Toronto Centre for Addiction and Mental Health show promise in the rapid improvement of symptoms. And remarkably, they also appear to renew the underlying brain impairments which give rise to memory loss. Well, the findings have been presented today. I'm delighted to say we can go to Washington and talk to the lead researcher on the project, Dr. Etienne Sibille, a neuroscientist and professor of psychiatry at the University of Toronto. Welcome to the programme, Doctor. Let me take this in stages, if I could. Presumably, to develop all of this, you've had to identify why there is memory loss in the first place.
Yes. So thank you for having me on the program. So the initial problem is that, you know, we actually know that they are what we call cognitive symptoms, memory, learning, making decision across most brain disorder, depression, schizophrenia, but also Alzheimer, and there are actually no drugs that target it. So they really know therapeutics that are available to target, and they really believe to be the core of to contributing to the core of these disorders.
And which bit of the brain have you had to target? And tell me a little more about the molecules you've actually developed.
Yeah. So that was you know, over the past few years, it was a multi-step approach. You know, first we went to the human brain because we figured that is where the pathology is. So we went to the frontal cortex, the amygdala, you know, different area located in the front that are known to be involved in cognition and mood. And we've done genetic, molecular analysis, identify specific cell type. And then we went to mouse model, genetic mouse model, if you want to go from what would be a correlation in human to a causality in mouse. And based on that, then we say, okay, how can we dissect this system now, identify a target, and develop new molecules? So that has been the strategy.
So you set it all up. Just take me through the results you have had, because they seem quite exciting at face value.
Yeah. So we identified a target, developed new molecule, and showed that these molecules get to the brain, they're safe, they stay in the brain long enough, and so they have some effect on mood. But the most exciting is the effect on memory, on working memory. So you can take a mouse, for example, and they can learn to negotiate a maze. They remember where they went, and you can train them, and they'll perform at 80–90% accuracy. Now, if you can stress this animal for a week, the performance will go down to 50%, which is basically by chance. Now, we give a single dose, 30 minutes after an injection, the animal, the mouse, will perform as, you know, back to full capacity. So basically reversing in a very rapid manner those deficits.
And how much does it reverse by?
Well, you reverse pretty much to control level. So you reverse almost, I would say, 90–95% the deficit. So that's in the context of depression, or if you want to model a depression. And then we went on to a model of aging. So you can take an old mouse, you don't have to do anything to it, you just put them in its maze, and it would have, you know, it would perform pretty much at chance level. And again, after a single injection, 30 minutes later, same as after 1 week or after 2 months, we can show that those old mice can now learn the task and perform pretty much at the level of young mice.
Sorry to interrupt you. That sounds incredible. I mean, in layman's terms, are you saying that, and I'll get on to when this could be done perhaps on humans, but are you saying that potentially you could have a 60-year-old, 70-year-old take these molecules and end up with a brain of maybe a 20-year-old, a 25-year-old?
Per 60. Well, in terms of performance, yes. So that was the first thing. So that is if there is a deficit. If the person doesn't have deficit, we show that those drugs do not work. So it's not a drug that's going to make you smarter than you are if you don't have any deficit. But in terms of rejuvenating, if you want, at the behavior level, yes. And the second part, if we want to talk, that you briefly mentioned, is what does it do to the brain itself? And that is really the second exciting part, you know, when we look. if you look at brain cells, with age, they tend to shrink. You know, they become smaller, they have less projection, and that's where the communication occurs. And after 2 months of treatment, we showed that those old mice had brain cells that were pretty much indistinguishable from those of young mice.
Yeah.
So we can reverse
let me
not
ask you just,
yeah?
let me ask you a final question. We've only got about 30, 40 seconds left. How soon potentially could you actually test this on humans?
So we're doing late preclinical study. We hope, if everything works well, to start our first phase 1, which is a safety study, in approximately 2 years. This would be probably for 1 year, and again, if everything works well in terms of results and funding, that's always an important question, then we'll be in proof of concept in the following years.
All right, Doctor, thank you. It's absolutely fascinating. Perhaps as you go further along the way of this research, we will talk again. Thank you so much for joining us there live from Washington.
Yeah.
We're going to take a short break. We're not far away from the first of those votes in the House of Commons. They've been debating for the last few hours. 4 votes we're expecting. Theresa May could be defeated. We're back in a moment with all of that in a moment or two.